International Space Station, known as ISS, is not just a scientific laboratory in orbit, it is the largest structure ever built by humanity outside the Earth's surface, a result of decades of extreme engineering, complex political agreements, and an operational routine that never stops. Orbiting at about 400 kilometers altitude, the ISS makes a complete orbit around the planet every 90 minutes. This means 16 sunrises and sunsets each day, while it operates continuously with crew on board. The idea of the ISS was born during the Cold War, when the United States and the Soviet Union fiercely competed in space. At that time, each station was national, isolated, and built as a symbol of power. Russia accumulated extensive experience with the Mir station, which operated for over 15 years. Modules were tested there, along with long human stays and life support techniques in microgravity. The United States, in turn, had Skylab launched all at once. It demonstrated the scientific potential of an orbital laboratory, but also revealed the limitations of a non-modular station. With the end of the Cold War, maintaining separate space programs became too expensive. The solution was unprecedented, joining forces to create a modular, international, and permanent station. The central concept of the ISS is modularity. No country would launch a complete station. Each module would be launched separately, docked in orbit, and integrated into a larger system. In November 1998, the first step took place with the launch of the Zarya module. Built by Russia and financed by the United States, it provided initial power, attitude control, and propulsion. A few weeks later, the Unity module is attached. It functions as a connection node, allowing other modules to be linked to the main structure. From this moment on, the ISS transforms into a permanent construction site in space. Astronauts begin to perform spacewalks to connect cables, install systems, and prepare new docking points. Robotics was essential. The Canadian robotic arm, the Canadarm, allows moving modules weighing tens of tons with precision, something impossible with human effort alone. Between 2000 and 2009, the large structural trellises arrive. They hold the solar panels, radiators, and main power and data lines. ISS. The solar panels are huge. When fully extended, they surpass the size of a football field. They generate enough electricity to power all systems and experiments. In space, there is no air for cooling. Therefore, the heat generated by electronic equipment is dissipated through radiators, which emit thermal energy in the form of infrared radiation. Inside, the ISS is made up of pressurized modules. Each module is filled with racks that function as technical cabinets full of computers, scientific experiments, pumps, filters, and electrical systems. Life support is critical. It controls internal pressure, air composition, temperature, and humidity. Any prolonged failure can put the crew at risk. Carbon dioxide is one of the greatest invisible dangers. Elevated levels affect concentration, vision, and can lead to serious problems. Therefore, the ISS has multiple redundant CO2 removal systems. Water is treated as a strategic resource. In addition to replenishment by cargo ships, the ISS recycles humidity from the air, sweat, and urine, transforming everything back into drinkable water. This technology is not just curiosity, it is essential for future long-duration missions, such as trips to the Moon and Mars. To stay properly oriented, ISS uses giant gyroscopes called control moment gyroscopes. They adjust the station's position without continuously using fuel. When these gyroscopes reach their limits, docked ships use thrusters to perform corrective maneuvers, ensuring stability. Even at 400 kilometers altitude, there is still a slight atmospheric drag. Over time, this reduces the station's altitude. To compensate for this loss, reboost maneuvers are performed, raising the ISS's orbit again. Another constant risk is space debris. Fragments travel at enormous speeds and can cause catastrophic damage. Therefore, the ISS monitors threats and executes evasive maneuvers when necessary. The crew's daily routine is meticulously planned. It includes maintenance, science, physical exercises, and safety training. Exercise is not optional. In microgravity, bones and muscles quickly lose mass. Astronauts train about 2 hours a day. The main objective of the ISS is scientific research in microgravity. Liquids form perfect spheres, flames burn differently, and physical processes can be observed without the interference of gravity. Experiments with protein crystallization help in the development of medicines and new materials with direct applications on Earth. The station is also a privileged platform to observe the Earth, studying climate, natural disasters, wildfires, and environmental changes. The operation of the ISS involves control centers in various countries. Everything is coordinated with strict protocols, standardized languages, and joint decision-making. Who funds the ISS? It is mainly maintained by the United States, Russia, Europe through ESA, Japan, and Canada. Each partner contributes modules, technology, launches, or logistics. Logistics is vital. Food, parts, oxygen, and new experiments arrive on cargo ships. Without constant resupply, the station simply cannot survive. But the ISS is not the only station in orbit. China built its own space station, called Tiangong, also known as the Chinese Space Station. Unlike the ISS, Tiangong is a national project. It is smaller, more compact, and was assembled quickly using China's experience from previous missions. The Chinese station is also modular, but follows a more centralized philosophy, with fewer international partners and greater direct control by the Chinese government. Comparing the two, ISS represents global and large-scale cooperation, while Tiangong demonstrates efficiency, rapid construction, and technological autonomy. In the future, new commercial and governmental stations are expected to emerge, leveraging the lessons learned from both the ISS and the Chinese station. Perhaps the greatest discovery of the ISS is not a single experiment, but proof that humanity can live, work, and cooperate outside Earth for decades. It is a scientific city in orbit, maintained by routine, discipline, and cutting-edge technology. If this story impressed you, there's still much more to explore. Follow us.